broad spectrum of the features that sharks have to make them the top predator that they are today. And my effects. So I'm going to start you out with a video, and I'm sure some of y'all have probably seen this video.
2 weeks ago, the world got around with Snuffy the seal, who washed up on shore injured and dehydrated. We now go live to Snuffy's triumphant return to the sea.
We are just moments away from releasing Snuffy, the rescued seal, back into the ocean. And now you see it, Snuffy's triumphant return.
Alright, so that was this year's Shark Week commercial. That's really our interpretations of sharks because that's all we really hear about. So, I mean, we think they're violent and we think they attack us for no reason, but it's really not the case. So to start out, we're going to give a little background of their habitat. The oceans are huge, and the sharks, they don't live all in one area. Most of them live in continental shelf regions because they're highly productive regions because the sunlight still hits it. There's a lot of food there, and sharks love those areas. However, there are some that live in like the deep sea and open ocean, and some even live really, really close to shore. As we've seen, we even caught one when we were on the boat. Sharks are really, they're top predators, and they're really crucial to the ecosystems. They keep everything in line, being the top predator, and some people, scientists call them super predators because they really have no natural enemies besides viruses and pathogens and all that kind of stuff. So, on to features and what they look like. The only thing exactly the same with all sharks is the gill slits. They all have 5 to 7 of them, and that's really the only common feature because sharks will change. They look different and they eat different because where they live, what they have surrounding them, what they eat, everything. So we have here a great white. And we all know what those look like because that's like the common shark that we see. But then we have up here the wabagong. It's a bottom-dwelling shark, and it looks distinctly different than the great white. So that's just 2 types of sharks of more than 500 species of them worldwide. So they drastically change in appearance. So now, on to the senses. Sharks have heightened senses, being the apex predator that they are. Everything is by far greater than us, and they even have a sixth sense, you may call it. And they've evolved those over many, many years and have decided, well, they didn't really decide, but they have just evolved to be where they live and so we'll start with the vision. Vision underwater is very, very minimal. The light spectrum is different than what it is above the sea on ground. So sharks have way different eyesight than we do. And whoever has the better eyesight is definitely going to be able to survive better or be able to find prey better. And sharks are like cat's eyes. They can illuminate the light so they can see better underwater, and they can see better than most species of fish. So now on to scent. Sharks have a way better scent than we do. They can smell substances, and I know it's hard to read, but over hundreds of meters underwater, and under 100 meters, they can actually pinpoint the exact location of prey. So it is kind of scary, I guess you could say, that with 100 meters away, they can tell exactly where you are. So taste, the decision is, up to them. Sharks have really, really good sense of taste, so they will actually try their food before they completely eat it. That's why a lot of the shark attacks that happen, sharks do not really like the taste of us. And they will take one bite and then leave because they think that we are nasty. We're not like the Smith Island cake to us. So the taste really lies with them. And a lot of scientists, they haven't really proved this yet, but they believe that sharks that have attacked a human before will not attack them again. Because they remember the taste, they know what they look like, and they know how they swim, and they just won't attack us. A shark will not attack us more than once in its lifetime. So scientists say. It's not proven yet. So now on to their sixth sense. It's electrosense, and they have what's called ampullae of Lorenzini. And these are jelly-filled sacs in the skin, normally around the nose area and the mouth, and they can feel electrical fields in the water. It has to be really close to them. That's the only downfall. But if there is a fish that's camouflaged with the ground or anything, they can sense it, know exactly where it is within a few meters, and be able to catch their prey that way. Hearing, sound travels really, really fast underwater, about 4 times faster than on land. And sharks have a keen sense of hearing because they listen to the low frequencies, because they listen to injured animals. They listen for that, and that's why they think they will attack us sometimes, because the way we swim, the frequencies in the water sound like an injured animal. So that is their hearing. They have a really, really in-depth hearing system. It's not really easy to tell here, but it's really, really precise on low frequencies, some things that we wouldn't be able to hear, and they can hear it hundreds and hundreds of meters away and be able to tell exactly where it is. And then the pressure sensors, they have the lateral line. It goes from their caudal fin, the tail, all the way up to their head, and there's jelly-filled sacs connected to sensors on the skin. And with this, they can tell difference in any type of pressure in the water, whether it be temperature, whether it be the change in water depth, water pressure, because something's moving near them. They can tell it and know that it's going to happen, know when it's happening. And it is a very useful sense for them, because if it's too cold for them, too hot, they'll move, and they can tell where their prey is near them. So on to the last slide. Sharks aren't so bad. And as you can see here, it really isn't that bad as we might say. So that's all about sharks.
Thank you, Cole. That was excellent. All right. Next up, we've got Molly Cleveland, who is going to talk to us about her terrapin research project and the research she did with them in this region. Something was wrong. Something is wrong. It's too cute.
It's too cute.
Look
I have
away.
a picture of Polaris. The one you took.
Mm-hmm.
Yeah.
Well, I know that. Well, I know he's cute.
I know he's cute. Wait, how did I use this thing? Okay. Let me see it. I don't know where to be. Okay, hi everyone. So this summer I worked with 2 undergrads from Kutztown University in Pennsylvania. I worked with Sarah and Pete, and they were working under Professor Dr. Stone, who...
Sorry.
Somebody pointed over there. Okay, they were working with Dr. Stone to study the diamondback terrapin of the Chincoteague Bay region. So under their research and their data, I completed my own project. So my research question was, what are the comparisons between the roadkill terrapins I find on the causeway and the live-caught terrapins we find in Mosquito Creek, which is alongside the causeway? So just some background information about terrapins. So their habitat, they live in brackish water and the intertidal zone. So they're a really unique species because brackish water is the water that is mixed between saltwater and freshwater. So they're really unique because of their unique habitat, and they have a lot of unique adaptations. So some male versus female descriptions and some shell descriptions. So females are actually larger than males, and males will be shorter and have longer tails and thicker tails. And then their shell coloring is somewhere from green, yellow to black. So it's very hard to determine its various colors. So some salt adaptations. The terrapins have adapted so that their skin does not allow salt to penetrate it, so that they stay more hydrated. They can live in various salinities, and they have a laryngeal salt gland that helps them with dehydration. And they've also adapted to several ways on gaining fresh water. So they will skim the top of the salt water with their mouths to gain fresh water, and then they've actually come to be known to catch falling rainwater in their mouths. So some physical adaptations that both male and female terrapins have very strong jaws for cracking open shells and clams and things like that. So reproduction. First I'll talk about courtship. So courtship or mating happens in May and June, and a female terrapin can have more than one mate, which means that all of the hatchlings in one clutch will be from different fathers. So it is known that a terrapin will have up to 3 clutches in the wild or 5 clutches in captivity, and clutch size is determined by the latitude at which they live. So for instance, in New York, the clutch size is 10 hatchlings, but in Florida, it's 5. So hatchlings, once eggs are laid, they are take about 7 to 10 weeks to hatch, and they emerge around August or September. So male versus female maturity. Males mature at ages 2 to 3, and a full-grown male will be 4.5 inches, and a female will be 6.75 inches when they reach maturity at age 6 to 7. So in the 1900s, the diamondback terrapin was hunted as a delicacy. It was a very high-class food. And so it was hunted, and the population went down drastically. And then they also get stuck under motorboat boats or trapped under crab and lobster nets. So that's another reason why the population here is dwindling. So from the information that I collected, I was trying to find a pattern between whether the population would be impacted by the causeway and all of the dead terrapins crossing the causeway. So for my information, I based it off if there was a dead female who was mature and was pre-egg, there was a population impact because that turtle was unable to lay eggs. If there was a dead female who was mature but was post-egg, the population impact was not as drastic because she had already laid her eggs. So I completed my project in 2 ways. The first way was roadkill collection. So the undergrads and I took all safety precautions to go out on the causeway using the safety light, orange vest, things like that. Basically, we just drove up and down the causeway looking for roadkill terrapins, and when we found one, we pulled off to the side and went out and determined if the specimen was appropriate to take with us. And then we also took it back to the lab for analysis, and we took down information like whether it was high or low tide, the temperature, the weather for the day, and then obviously various things about the shell and the turtle itself. The second part was the live trapping collection. So we collected in Cockle Creek and Mosquito Creek, which is right up against the causeway. We would check the traps that the undergrads had set for terrapins, and then we also did cast netting. And cast netting is where you take a net and you make sure it's untangled. It's a round circular net that's weighted down. And what you do is you take a section of net between your teeth, you take 4 arms length, and then when you see a terrapin in the water, you'll see a little black head or a white mouth, and you'll launch it like a frisbee at them, and then you quickly pull it back to trap them in. So I have a video. Oops, okay, I have a video after. So this is roadkill collection. On the right, on the left, you see Sarah. She's cutting out the femur of one of the dead specimen to age the turtle. We also used the shell, the rings like a tree on the turtle's shell, did the age. And I didn't know if I should smile or be sad about my first roadkill terrapin, so I just smiled. It was the best thing I could do when Paige took the picture, so, you know, whatever. With our roadkill terrapins, we took the viable eggs from females who had not laid their eggs yet, and we tried to hatch them here at the MSC. Our first baby was born on July 30th or 31st. His name is Polaris because he was our undergrad's shining star throughout the summer. He is baby boy who was released while we were on our intern camping trip. So I think he was released Monday. And that's his whittle head, and he's adorable, and he took almost 24 hours to finally hatch. So, and it took him about I think it took him 9 weeks to hatch after he was. So trapping collection, these are 2 pictures of me throwing and putting a very salty and yucky net between my teeth. And I have a video? I guess I don't have a video of me throwing. Okay. Oh well, sorry. So these were our roadkill results. Unfortunately, Sarah and Pete left before I could collect all the data from them, and the professor was unable to give me half of my data. So I was unable to compare the ages of the roadkill terrapins I found to the live caught terrapins I found. So I quickly changed topics and I'm just going to focus on the ages of the roadkill terrapins, and I tried to determine what ages and whether they were pre or post egg to figure out if there was a correlation there. So as you can see in this slide, the ages of the roadkill terrapins, typically the ones found that were post egg, are the 8 to 11-year-olds. Anywhere from 5 to 7, they were pre-egg, and anywhere from 12 and up, they were pre-egg. So that's a really large range, except for the 8 through 11. So for the 8 through 11, we collected 4 specimens that had no viable eggs. For age 9, we collected 5 specimens. 10, we collected 9 specimens, and for age 11, we collected 3 specimens. So from that data, I was able to determine that this age range is the ages where the terrapins are crossing the causeway only after they've laid their eggs. So the 5 and below and 12 and up is a very large age range, and so it basically means that the only surviving baby terrapins are within this age range, which means the population is still dwindling because of the 5 and 12 age ranges. So, in conclusion, the population is not being decreased by the 8 to 11-year-olds, but is being decreased by the 5 and 12-year-olds. And these ranges are really broad, so we still really need to focus and put a lot of effort into trying to preserve one of the native turtles here because it's very vital to this unique ecosystem. And I wanted to thank all of the staff here at the MSC for an amazing summer. It was great and I really enjoyed it, and I couldn't have asked for a better way to spend my summer into senior year. I wanted to give a huge shout out to Paige and Blair, who made our summer also incredible, and they were very helpful and helped with anything we needed, especially my homesickness the first week. I appreciate it. Okay, best of luck to all the interns during their senior year. I will miss you guys, but we're all going to do great.